Welcome to The Explainer. Okay, imagine for a second that your medical records, all the crucial information that could literally save your life, are stuck in a system that was built back in the 90s. Today, we're going to pull back the curtain on the unbelievably complex, high stakes process that hospitals go through to make sure that nightmare scenario never, ever happens. So here's our roadmap. We're going to follow the entire journey of a hospital's IT overhaul. We'll start with that first huge decision, then we'll dig into the blueprints, talk about how these systems get built and tested, and finish with that heart-stopping moment when they flip the switch. All right, let's dive in. So let's put you in the driver's seat. You're the chief information officer at a hospital we'll call St. Jude's General, and you've got this exact problem. And let's be clear, this isn't just some tech upgrade. No, this is a fundamental decision that's going to affect patient care, how your staff does their job, and really the hospital's entire future. Okay, so the first major hurdle for St. Jude's is a big one, a real fork in the road. Do they build a completely custom system from scratch? Do they buy a ready-made one off the shelf? Or do they subscribe to a service online? And what you're seeing here is really the core dilemma. Building your own system is kind of like getting a custom-tailored suit. It's going to be a perfect fit for how St. Jude's already works. But the downside? It costs an absolute fortune and can take years. Buying or subscribing, on the other hand, is like grabbing a suit off the rack. It's way faster and cheaper, but now your staff has to change to fit the software, not the other way around. You know that subscribe option? It's called SaaS, and it's massively popular in healthcare these days. And it's easy to see why. Think of it like Netflix for your hospital's most important software. St. Jude's just pays a subscription fee, they get access to a cutting-edge system, and they never have to worry about maintenance or updates. For a lot of hospitals, this is a total game changer. All right, so let's say St. Jude's has made its big choice. Now, before they write a single check or sign a contract, they have to enter what is arguably the most critical phase of the whole project, laying the groundwork. This is where they draw up the blueprint. And this is so important. You wouldn't build a house without a blueprint, right? Well, you absolutely cannot get a new health information system without doing a deep, thorough systems analysis first. This is where the team really digs in to understand exactly what they have now, what they desperately need, and what's actually possible. And what's really crucial to get here is that this stage isn't about picking out the shiny new software yet. Not at all. It's about deep investigation. The team at St. Jude's is going to be down in the trenches, you know? They'll be interviewing nurses, shadowing doctors, mapping out every single click and form to define what success actually looks like on the hospital floor. And what comes out of all that digging is a list of requirements. These are the specific, non-negotiable features the new system absolutely must have. A requirement isn't just some vague wish. It's a very precise demand. Something like, this system must be able to communicate perfectly with the blood analyzers in our lab. Honestly, getting these requirements right is the single most important part of this whole phase. Now, let's circle back. If St. Jude's decides to go all in and build their own system, they have to pick a development methodology. And trust me, this choice is going to have a massive effect on how the entire project plays out. So you can think of the waterfall method like a traditional car assembly line. First, you complete the entire design phase. Then, and only then, you move on and complete the entire coding phase, then the testing phase, and so on. Every single step has to be totally finished and signed off before the next one can even begin. It's very rigid, very predictable, and very controlled. But here's the biggest problem with that whole assembly line approach. It's incredibly inflexible. Imagine a surgeon realizes, 6 months into the project, that they forgot a critical feature for the operating room. Well, with Waterfall, going back to change that original blueprint is just unbelievably disruptive and expensive. The modern alternative to that is Agile. So, instead of one giant, multi-year project, the team delivers small, working pieces of the software every few weeks in these little bursts called sprints. This is huge because it lets the doctors and nurses at St. Jude's actually test out new features as they're built and give immediate feedback. It ensures the final product is something they can actually use. So, whether St. Jude's decides to build or buy, no system, and I mean no system, goes live without some serious, rigorous testing. This is where you find all the bugs and the workflow problems before they have any chance to affect patient care. First up, you've got integration testing. The best way to think about this is making sure the hospital's digital nervous system is all connected, right? So when a doctor in the ER orders a medication, does that order pop up instantly and accurately for the pharmacist 3 floors down? When a patient gets discharged, does the billing system know about it automatically? If these different pieces don't talk to each other, the whole system just falls apart. And that brings us to what might just be the most critical step of them all: user acceptance testing, or UAT. This is the real moment of truth. You hand the system over to the people who are actually going to live with it day in and day out. The question here isn't, does the code work? The question is, can a nurse at 3 a.m. during a totally chaotic shift quickly and easily chart a patient's vitals? That is what really matters. Okay, this system is built. It's been tested from top to bottom. The entire hospital staff has been trained on it. And now comes the single most nerve-wracking moment of the entire project: the go live, or cutover. This is when you turn off the old system and turn on the new one. To really understand the massive stakes here, let's take a quick look at a famous case from outside of healthcare. Way back in the late 90s, the chocolate giant Hershey's decided it needed a new system to manage all its orders and shipping. And they planned to launch it right before Halloween, one of their absolute busiest times of the year. So they decided to go for it. They chose to just flip the switch all at once. A really high-risk, high-reward move. They turned off their old, reliable system and turned on their brand new, super complex one at the exact same time. Any guesses how that worked out for them? It was a complete and utter catastrophe. The new system totally failed. It left Hershey's completely unable to process and ship an estimated $100 million worth of candy. And this brings us to the specific name for the risky strategy they used. This is what Hershey's did. It's called direct conversion, but most people call it the Big Bang approach. Sure, it's fast, but if anything at all goes wrong, you have absolutely zero safety net. For Hershey's, that meant a $100 million loss. But in a hospital, a failure like that isn't measured in dollars. It's measured in delayed treatments, medication errors, and potential patient harm. The stakes are just infinitely higher. But thankfully, for a hospital where actual lives are on the line, there are much, much safer options than the Big Bang. St. Jude's could do a phase-in, maybe starting with just the patient scheduling part. Or they could pilot it in just one department, like cardiology. Or, for the absolute most safety, they could run both systems in parallel for a while, making double sure the new one is perfect before finally pulling the plug on the old one. So, from that very first choice to build or buy, all the way to that final, heart-stopping moment of flipping the switch, every single step is just loaded with risk and opportunity. This is so much more than an IT project. It's the digital backbone of modern medicine. The next time you're in a hospital, just think about the immense invisible effort that goes into the technology that's working silently in the background, keeping you safe. The real question isn't just how a hospital gets a new system, but how they make sure that system is ready for the life or death decisions of tomorrow.